Hi, let's now look at partial derivatives. So we are told that given that z is equals to 2x squared plus 3xy plus 4y squared, and u is equals to x squared plus y squared, and v is equals to x plus 2y, we first of all have to find our partial of x with respect to u and partial of y with respect to u. So for the first part, the best thing to do is to first of all find my partial of u with respect to x, which is more like the opposite of that, if I would call it like that. So this is going to be equals to, if I partially differentiate that one with respect to x, I'm just going to get 2x because I'm treating y as a constant. Then if I get my partial of u with respect to y, this is going to be equals to 2y. Okay, let me also determine what my partial of v with respect to x is, because I'll need this when using Jacobean to come up with my partial of x with respect to u. So partial of v with respect to x is equals to 1. Okay, then the last one, which is partial of v with respect to y, will be equals to 2. Okay, so to use Jacobean, okay, to use Jacobean, where we say this is going to be equals to, it's more like partial of this would be u, um, uv there, then partial of, you're going to have xy like that. This is just equals to, it's just equals to, here you're going to have your partial of u with respect to x, then here you're going to have a partial of u with respect to y, here you're going to have a partial of v with respect to x, with respect to x here, then here you have your partial of v with respect to y. Okay, so now this is just going to be if we substitute here partial of u with respect to x, we have found 2x, then down here we're going to have 2y, then here we'll have 1, and here we're going to have a 2. Okay, so what we do is just more like you're finding the determinant, major diagonal minus minor diagonal, of which our major diagonal is just going to be 4x minus our minor diagonal, which is 2y. Okay, so we have determined that our Jacobian, that is just equals to, I can say 2x minus y. That's what we have. Okay, so now let's now use what we have to get what we want. And I think before I even erase this, we might need a part of it to gain the understanding that we need. Okay, so I'm just going to copy this and just place it there. So we said j is equals to that. Okay, so now let's now determine our partial of x with respect to u. How this is going to be is that you're going to say your partial of x with respect to u is just going to be equals to, so remember, here you have your partial of u with respect to x, but you want your partial of x with respect to u. Okay, so what you're going to use is what is down here. Okay, and we are in the major diagonal, so you're going to pick the positive part of it, which is the partial of v with respect to y, and you're going to divide this by what, by the Jacobian. So what was here is that it's this one here, which is what, which is a 2. So you're going to say 2 divide by 2, then you have your 2x minus y, you close, and your answer is just going to be 1. Okay, 1 over 2x minus y. That's what you get right there. Okay, so we have determined that our partial of x with respect to u is just equals to 1 divided by 2x minus y. So it's just more like picking what is opposite it, like that, like in terms of diagonals. So you can pick that one if you're looking for partial of x with respect to u. If you're looking for a partial of y with respect to v, you pick that one, divide by Jacobian. If you're looking for as we are looking for partial of uh, looking for partial of y, okay, you're looking for partial of y with respect to u, this will be equals to, so here we have partial of u with respect to y, but I'm looking for partial of y with respect to u. This is just going to be equals to, this is in the minor diagonal, so it will be minus that, because this is in the minor diagonal, so I'm going to subtract, because I have like positive here then negative there. Okay, so that would be minus my partial of v with respect to x divided by Jacobian. So this will be minus, what's my partial of v with respect to x is a 1, so that's just going to be 1, okay, divide by my Jacobian, which is let me just write it as 4x minus 2y. So we have determined that our partial of y with respect to u is simply equals to minus 1 divided by, we have our 4x minus 2y there. Okay, so we have answered the first part. Then the question further says um, it further says hence or otherwise find partial of z with respect to u. Okay, partial of z with partial of z with respect to u. So our partial of z with respect to u is just going to be equals to partial of z with respect to x multiplied by partial of x with respect to u, which is what we have there. Okay, then we are going to say plus partial of z with respect to y multiplied by partial of y with respect to u, which is what I already have here. So it was very important that we find the correct expression for that one. So this is for the second question, for the second part, remember, which is this one here. So we said our partial of z with respect to is just going to be equals to, what's our partial of z with respect to x? So this is our z right here. Okay, so we just have to differentiate this one with respect to x, and I believe we are going to get something like that's going to be 4x, okay, plus 3y for this part. If the power is going to drop, that's going to be a 4. Then here when you get rid of the x, because that's just going to be a 1, you're going to have a 3y. So you're multiplying by partial of x with respect to with respect to with respect partial of x with respect to which is this one. So just more like you're just going to divide this. Okay, just going to divide this by 2x minus y, so that will be plus, then partial of z with respect to y, so you differentiate your z with respect to y, you're just going to get 3x plus 8y. Okay, then this will be multiplied by what you have here, and one thing that stands out, that this is just going to be a negative, that would be, we can make this a negative, then divide by 4x minus 2y. Okay, so let me just write this properly and say partial of z with respect to u is just equals to 4x plus 3y divided by 2x minus y minus 3x plus 8y there, divide by 4x minus 2y, and this is what we get for the second part here. And the first part, we understand it to say we just have to use Jacobian for that one. You just have to be careful as you pick in the minor diagonal, make sure you pick negative, then in the major diagonal just pick the positive. Okay, so that's how we answer that one. Thank you very much for watching.